I'm Sriram Ramaswamy. I teach physics at the Indian Institute of Science, which is in Bangalore. And it's a sort of science university in general with all subjects in science and engineering. And of late, it also has undergraduates. It used to be a completely postgraduate institution. So a couple of years ago, I was contacted by people organizing the program. The program overall is on something called anti-diffusive dynamics, which is technically a bit of a mouthful, and what it means is dynamical processes in which things tend to accumulate. Normally, you have a lot of stuff in one place, it spreads. But dynamics in which, when there's some stuff in one place, more of it piles up in that place, is in the maths trade called anti-diffusive. This class of phenomena can occur for many different reasons. It can occur because things are condensing, because they attract each other. It could happen because of some other layer or pattern forming tendency. It can happen on scales from oceans and planetary atmospheres down to little cell containers with a few swimming organisms. So there's many different settings in which it arises. And I remember Pat Diamond and Rahul Pandit contacted me years ago asking if I'd be interested in being part of this program. At some stage, I had the impression that I was supposed to be part of some kind of advisory group on it also, but at some point I was asked if I'd speak in it. The program itself has people drawn from many different disciplines. This past few weeks, the coming weeks, is mainly people working on much larger scale flows, planetary atmospheres, the ocean, and phenomena of that sort. But there's a few of us right now who work on problems typically at a much smaller scale in living tissue or colloidal suspensions or things on sort of lab scale, things you can hold in your hand. When I said that I'd like to come to the beginning of the program and then to a workshop later at the end, they decided to ask me to speak in the workshop at the beginning as well as later. So this workshop's been funny. It's been mostly people working on those larger scales, but the first three talks were by three of us, Ray Goldstein, Mike Cates, and me, working on what we call active matter, which is collections of particles that move by themselves, by their own power, living things typically. So that's how it happened. Although I've given broad lectures on the kind of thing I work on many times, this one poses a challenge. One, it has to place the kind of thing I work on, which is the collective behavior of self-propelled or autonomously motile things. It has to place it in a context relevant to this program. And this program overall is on anti-diffusive processes. So what I'll do in my lecture is, one, I'll tell you what I work on, which really I already mentioned is on collective behavior of living stuff or imitations of living stuff. But the other is to explain why phenomena in this area are akin to phenomena that other people in the program working in entirely different settings, from the oceans to atmospheres or to the cosmos, could be interested in. So I'm going to try to draw at least mathematical connections between what I do and what other folks in the program do, but I'll try to do it in such a way that someone with a broad scientific interest will see the point of it. So that's the idea, that's the aim.